Ions, isotopes, and average atomic masses. We know that atoms have protons and neutrons in the nucleus, and the electrons are in the vast space between atomic nuclei. Electrons have a negative charge. Often atoms gain or lose their least tightly bound, or valence electrons to form ions. The loss of electrons leads to the atom having more protons than electrons, or a positive charge. Positively charged ions are called cations. Metals often lose electrons. When an electron is gained, the ion has a negative charge. Negatively charged ions are referred to as anions. Nonmetals can form anions. However, hydrogen is known to form both a cation and an anion, depending on the circumstance. Notice how certain columns of elements take on a particular charge. You should know these. The first column on the left contains metals that naturally form an ion with a +1 charge. The next column over has metals that develop a +2 charge. On the other side of the periodic table, the halogens have a -1 charge, and the elements just to the left of them a -2. In addition, aluminum, gallium, and indium develop a +3 charge, zinc and cadmium a +2, and silver a +1. When different ions and neutral elements have the same number of electrons, they are referred to as isoelectronic. This slide shows two series of ions isoelectronic with a noble gas. Noble gases don't form ions in nature. Don't confuse isotopes and ions. Isotopes of the same element have the same number of protons, that is, the same atomic number, but a different number of neutrons. Therefore, they have the same mass number. The term isotope does not mean that the atoms are radioactive. In this slide, we have the three most common isotopes of the element neon. Notice that they all have 10 protons but vary in the number of neutrons. Also note that they are not equally represented. In a representative sample of neon, more than 90% of the atoms will be neon 20. This slide shows an approximate representation of the number of neon 20, 21, and 22 atoms in a sample of neon. Here are two ways to write the symbol for an isotope of element X. To determine the atomic mass of an element, we have to take into account that the isotopes are not present in equal amounts. This means that we cannot take the masses of the isotopes, add them up, and divide by the number of isotopes. We must take the percentages of each isotope into account. We call this working with weighted averages. To take a weighted average, we take the mass of an isotope and multiply it by the percentage of that isotope makes up. We do that for all the isotopes and then add the interim results together. Chlorine is just under 76%, chlorine 35, and just over 24% chlorine 37. Note that the average mass of chlorine is closer to 35 than 36. If you do this problem out like in the previous slide with chlorine, you will find that the average mass of magnesium atom is 24.3.